So the last section we're going to look at this week is 4.2, and this is on sketching rational functions. So we're going to use the graphing calculator quite a bit. We're also going to use asymptotes, horizontals and verticals that we studied yesterday. And we'll talk a little bit about intercepts as well. If we can find asymptotes where the graph crosses the axis and use the calculator, we can get a pretty good picture. Now, when you graph something like this, x minus 3 over x plus 2, what value would make the denominator 0? Negative 2. And where would your vertical asymptote be? And what would be the equation of it? X equals negative 2. Does everyone agree x equals negative 2 is a vertical asymptote? Okay. Now, what if you were to graph this? What value can you not use for x this time?
Negative.
It's still negative 2. But what's going to happen at negative 2 now? It's going to be a hole, right? It's going to be like a gap in it. So when you draw it, it looks something like that. It'd be basically the x plus 2's would cancel, and you'd have a line with a slope of 1 and a y-intercept of negative 3. It would look exactly like that, but there'd be a hole in it. Okay, so just a reminder that if the numerator and the denominator have a common factor, you can get a gap or a break in your graph that you can't see on the calculator. So the only way that you know it's there is if you go back to the original problem and you look at that. So common factors in the numerator and the denominator lead to what I've been calling a hole in the graph. No common factor, vertical asymptote. All right, let's try graphing something. I'm going to put in x minus 1 divided by x minus 1. Okay. First, is there a value that you cannot use for x? 1. Can't use it. Is it going to be a vertical asymptote at 1? Or is it going to be a hole at 1? It's going to be a hole. So that means when you graph it, are you going to see it?
No.
It's going to go right through the number, oops, let me do zoom 6. It's going to go right through the number 1. Like there's no problem at all. Okay, you're dividing two things that are the same. When you divide two things that are the same, what do you get? 1. That's why this looks like a horizontal line at 1. But there's a hole in it at the number 1. So we should have like an open circle right there on the graph. Is there any question why there's a hole in the graph at 1 and not a vertical asymptote? Okay. What could I do to the top to make it so instead of 1 being a hole, it is a vertical asymptote? Yeah, we could just change it to a plus 1. Now you still can't use 1, but it's now a vertical asymptote instead of a hole because there's no common factor. Okay, any question on that? Okay, so the real name for that, it's called a removable discontinuity. That's the name of a hole. It's called a removable discontinuity. So if you see a question on the test in the homework that says, does the following graph have a removable discontinuity? It just means, does it have a hole? That's all. And in our particular problem, the whole was at 1. The whole is not always at 1. Depends on what value makes the denominator 0. Okay, but there were no vertical asymptotes in that last problem until we changed it. Any question on that? Just a different term for a whole. Alright, so when we do a problem, we're going to have a polynomial in the top, and we're going to have a polynomial in the bottom. That's what that represents. So it just stands for some polynomial in the top and another polynomial in the bottom. Generally, the exponent goes down 1 each time. So it might start out with like x to the 4th, x to the 3rd, x to the 2nd, x, and then the last number is usually just a constant. Okay, same thing in the bottom. Starts out at the highest exponent, goes down 1 exponent, goes down another one, another one, another one, until you finally end up with just a constant at the end. There's a couple examples. Now yesterday somebody asked me, is there a way to figure out horizontal asymptote without sketching it? And I said we're going to talk about something called an EBM. EBM. We talked about it before when we did polynomials. Okay, the EBM was the highest degree term. And remember, if we graph the EBM and you graph your polynomial, you could zoom out far enough and they would look the same. So the EBM is basically it's a big picture of what your polynomial looks like. Right? It's like a simplified version. What would be the highest degree term in the top of that? Yeah?
ANXN?
Yeah, a sub n x to the n. Yep. That'd be the highest degree term in the top. So we would call that the EBM of the top. What would be the highest degree term in the bottom?
And of like the EMX.
Yeah, the first one, b sub m x to the m. That would be called the EBM of the bottom. To find the EBM of the whole thing, what do you think we would do with the EBM in the top and the EBM that's in the bottom? Do what? Yeah, we would divide them. So the EBM of the whole thing is when you divide the EBM of the top by the EBM that's in the bottom. Okay, so I just said that part. So the first term is the EBM of the top. The b sub mx to the m is the EBM of the bottom. And this is the EBM of the whole thing. Take the EBM of the top and divide by the EBM of the bottom. So let's say you had something like 4 divided by 8, and this was x squared over x cubed. That's an example of something you could have. Well, the first thing you can do is you can simplify your numbers. What is 4 over 8 reduced to? That's a half. Now we have to simplify the letters. We have x squared over x cubed. If you're not sure how to simplify it, think of it like this. That's x squared. That's x cubed. And where is the x going to end up? It ends up in the bottom. Does anyone remember what the rule is? You can actually find it without writing all these out. You just take this number and do what? Yeah, you just subtract them. You subtract the one in the top minus the one in the bottom, and that gives you an x to the negative 1. But whenever you have a negative exponent, that just means to put your letter where? Where? In the bottom. Okay, when you have a negative exponent, right, from algebra 1, that means you put the exponent in the bottom. So that's the pattern in general. Divide the two numbers in front, and then subtract your exponents. But don't leave x as a negative. Okay? If it's a negative, put it in the bottom. That's what negative means. And EBM is what's going to help us find the horizontal asymptote without having to sketch anything out. Yeah.
What do you mean exactly, like put it in the bottom?
So like if you had something like 3x to the negative 2, we generally don't want to leave an answer with a negative exponent. So you have to take x to the negative 2 and put it in the bottom. But when you put it in the bottom, it becomes a positive exponent. So it's 3 over x squared.
Okay, I get it. Thank you.
Any other questions on that? I'm not saying it's always going to be negative. I'm just saying if it does come out negative, put it in the bottom. If it comes out like that, well, then just leave it. It's not a negative exponent, so you don't have to do anything. All right, so let's try the EBM, and then I'll show you how to use it to find the horizontal asymptote. Okay, so what's the highest degree term in the top? Yep.
2x squared.
Right. Always check the whole thing, just in case they didn't put it in order. It should be in order from the highest exponent to the lowest, but it doesn't necessarily have to be. Okay, so that's the highest degree term in the top. What's the highest degree term in the bottom?
3x cubed.
3x cubed. So we have the EBM of the top, we have the EBM of the bottom, and what do we do with them to get the EBM of the whole thing? Divide. So the EBM is 2x squared over 3x cubed. When you're done, you should only have an x either in the top or the bottom. If you still have it in both, you haven't simplified it. So in this one, where are my x's going to end up? And how many of them will be in the bottom? Just one. So what's going to be my EBM that I put in that box? Yep.
2/3 x.
Yeah, 2 over 3x. Because the x is going to be in the bottom. And that's it. That's your EBM. So the idea here is if you put this in y1 and you put the original problem in y2 and you zoom out far enough, they're going to look exactly the same. This is like a simplified version of that. And the reason it's simplified is because pretend x is in the millions. If you square something in the millions and double it, then you square something in the millions, double it, and minus 1 from it. Does minusing 1 from it make a big difference? Not when you're dealing numbers that are in the millions or billions. Minusing 1 is basically, it's not important. So that's why the minus 1, it just goes away. Right? So this is a simplified version of what's going to happen. Okay. Now, the horizontal asymptote. What do we let happen to x if we want to find a horizontal asymptote? We let x get bigger. How big? How big do we let x get if we want to find a horizontal asymptote? which would be getting how big? Infinity, right? You let x approach infinity. As x approaches infinity, whatever happens to that box is your horizontal asymptote. So what happens to what's in this box as x approaches infinity?
It also approaches.
So if you let x be 1,000,000,
Yeah.
what's 2 divided by 3,000,000? Is that approaching infinity? Approaches zero.
Zero, yeah.
Yeah. So the horizontal asymptote is getting closer and closer to 0. So how would I write that? Y equals 0. Yeah. So you let x get bigger and bigger and bigger and bigger. Right? Like, if you're not sure of a number, you're going to try 1,000,000. 1,000,000 times 3 is 3,000,000. So the denominator gets huge. That means the entire fraction gets small. And that's it. That's how you find an EBM and use it to get the horizontal asymptote. Yep.
Notice that in one of the last problems that you did, it was kind of the same situation where it was x squared on top and x cubed down below.
Mhm.
And you moved the x outside. When this one, it stayed in the bottom.
With a -1, I had it on the outside.
Yeah.
Mhm.
What made you do that?
So when you do 2 minus 3, you get -1. And that's what the formula says to do. Subtract top exponent from the bottom one. But when you have a negative exponent, we always want to make sure we put it in the bottom. That's just a rule for negative exponents.
So if it's on the outside, you move it to the top and then move it to the bottom?
Only if it's a negative exponent.
Oh, but it has to be in the top to begin with, to then move it down.
Yeah, you'd never end up with a negative in the bottom. You just end up with a negative like this, just like right next to it. So if you end up with a negative, then really that means the answer should go in the bottom. So like, what if you had this? You can leave it with a negative for the first step. That would be x to the what? That's x to the -8. Which really means what if you write it with a positive?
1 over x to the 8th.
1 over x to the 8th.
Okay.
That's what we're looking for.
So you're just taking x to the -8 and then just making it in fraction form.
Yeah.
Because it's moving back to decimal places.
Uh,
If it was a decimal.
no, there's nothing with decimals. The rule is just if you have a negative exponent in the top of a fraction, you move it to the bottom and it becomes a positive exponent. So we did that one. All right, let's try this one. Okay, what's the highest degree term in the, or I could just say, what's the EDM at the top? Yep.
2x to the 4th.
So 2x to the 4th. And the EDM of the bottom. Yep.
3x to the 4th.
3x to the 4th. So that simplifies and gives us an EDM for the whole thing of
2 over 3.
2 over 3. Now, to find the horizontal asymptote, I'm going to ask exactly the same question I did last time. Look at what's in that box and let x get bigger and bigger and bigger. What happens to what's in this box as x gets bigger and bigger and bigger? There's no x. So what's in the box is going to basically stay as what? It's going to stay as 2 over 3. There's no x there. So what would your horizontal asymptote be?
2 over 3.
What would be the full equation?
Oh, x equals 2.
Y. So that's something that can happen if the powers are the same. They will completely cancel. There will be no x left. And all you get for the EDM is basically the numbers that were in front to start with. Any question why the x to the 4th completely disappears there? So the last thing we're going to do is we're going to try a sketch. So we'll probably do one sketch today. We can do another one tomorrow. For today, the problem I'm going to show you and the problem in the homework is going to be sketching a graph where the numerator has an exponent that's smaller or equal to the exponent in the bottom. So the exponent in the top will be smaller or equal to what's in the bottom. Like this one. It's smaller than what's in the bottom. Or like this one. They're equal. We're not going to do it where it's bigger until later. Okay, so these graphs are going to curve. So there's a few different things we got to find to sketch it. It's not as simple as drawing a straight line. It's not quite that easy. But a couple things that we can try to find are the intercepts, where the graph crosses the x-axis and where it crosses the y-axis. Now, just a reminder on how you find intercepts. If you want to find the x-intercept, let's say you had this problem. That's just y equals mx plus b. We're not working with equations that simple, but it's the same idea. If you want to find the x-intercept in this graph, you'd fill in a 0 for y and then solve it. If you want to find the y-intercept, you plug in a 0 for x and then solve it. Okay, so some people mix that up. So the x-intercept, 0 for y, y-intercept, 0 for x. The next thing that we're going to want to try to find is the vertical asymptotes. Okay, reminder from yesterday, that is the zeros of the denominator. Next thing we're going to do is what we just did in the first two examples today. We're going to find the EBM, and then we're going to use that to get the horizontal. As far as what we do by hand, that's pretty much it. Step 4 is going to be to use the calculator. Let's say we get a vertical asymptote. I'm just going to pick a number, like 2. Well, you can't plug in 2. If you plug in a 2 in your table, you're going to get an error. But you can plug in a number near 2. Okay, and when I say near 2, I'm thinking like 1.999, like something very, very close to 2. So we want to see what happens as we get close to the number 2 on each side of it. To the left of it, so that'd be like 1.99, and to the right of it, like 2.001. What usually happens as you get close to a vertical asymptote? What happens to your y value? It usually does one of two things. Either goes up or it goes down. So as you start to get close to a vertical asymptote, it's going to go up very high or down very low. We just have to see which side is which. Which side is going up, which side is coming down. And then we can just double check, make sure we get the right picture by looking at it on the calculator. So we'll try one of those, and that'll be it. Everyone have the 1 through 5 steps.
Just need to write the last one.
Last one? Yeah, the last one is just confirm with the calculator. Okay, so here's your graph. F of x equals x minus 1 over x squared minus x minus 6. First thing I would do right away is you're going to have to find where the denominator equals 0. That's for your vertical asymptotes. So we should factor it. You don't have to factor it to do everything, but you're going to have to factor it at some point. So let's get that out of the way. What would be the first term in each factor? And whenever you have a negative for the constant, what do your signs always have to be? Right, because you got to multiply two things to get a negative. And I need two numbers that multiply to give me 6 and subtract to give me 1.
Positive 2 and negative 3.
Yeah, or negative 1. So yeah, we're going to need a positive 2 and a negative 3. That looks good to me. Okay, so that'll save us a little time as we do it. Okay, did I write? No, I didn't write anything down. Okay, so let's start with the intercepts. Let's do the y-intercept first. The y-intercept is when you let what equal 0? X. Okay, let's plug in 0 for x and see what we get. What's 0 minus 1? Negative 1. What's 0 squared?
0.
Minus 0?
0.
Minus 6. Negative 6. So there's your y-intercept. It's at 1/6. Let's do the x-intercept. The x-intercept is when you plug in 0 for this. So you'd have 0 equals x minus 1 over x plus 2, x minus 3. It looks like it could be kind of hard, but it's not. When you have a fraction equal to 0, what's the only way that a fraction can ever equal 0?
If the numerator is 0.
Just if the numerator is 0. So all you need to figure out is what number makes the top 0. Yeah, 1. There's your x-intercept. X equals 1. All right, what else? Find the vertical asymptotes. That's where the denominator is 0. Okay. Since we factored it, we should be able to see the two numbers that make the denominator 0. What makes the first factor 0?
Negative 2.
Negative 2. And the second one?
3.
3. Okay, so write those down. Okay, verticals and EDM. What's the highest degree term in the top? X. Okay, x. 1 is a constant. That's degree 0. X is degree 1.
I think that's what the degree was.
So highest degree term, yeah. So x. And what about the highest degree term in the bottom? X squared. Let me fix that. Okay, so x over x squared. Yep. And what does that reduce to?
1 over x.
1 over x. And now, look at x, and let x get bigger and bigger and bigger and bigger. What's going to happen to what's inside that box? It's going to get closer to 0. So what's your horizontal asymptote?
Y equals 0.
Y equals 0. Okay. And that's everything that we need. Now we just have to put that on the graph, and then we'll do step 4, which is to use the calculator. But as far as doing stuff by hand, we're done doing stuff by hand. Okay. Horizontal asymptote at 0. Vertical asymptote at negative 2. Vertical asymptote at positive 3. Good enough. These graphs are usually in 3 pieces. There's one piece to the left of the vertical, one piece between the verticals, and then one piece to the right. So we've got to kind of check out each piece. What was my y-intercept?
6.
Okay, so it doesn't really help me in y. It just tells me it crosses a little above the origin. And my x-intercept? 1. Okay, so I got 2 points very, very close. If you're going to cross the horizontal asymptote, which this one does, you will always cross it between the verticals. You'll never cross it outside the verticals. All right, now step 4. Evaluate the function near each asymptote. Well, I need to type that in first. So let's put in x minus 1 divided by, I'm typing in the original because it's less parentheses than the factored version. I needed the factored version, but I'm kind of done with that now. So x squared minus x minus 6. Okay, I have to always go to second window and make sure mine's on ask, just like that. Okay, what was our first vertical asymptote? -2. So you can't plug in -2. You're going to get an error. But you can plug in something near -2. What's a number that would be just to the left of -2, but extremely close?
-2.1.
Yeah, -2.0 or 0.1. And we're down at -600. So if you come at it from the left, the graph is going to be way down. It's going to be like way down there. It's the best idea. It's way down. Now what I want to do is check what happens as you get close to -2 on the right side. So what's a number that's a little bigger than -2?
-1.99.
-1.99.
Oh.
And we're up at 600. So on one side, we're down very low. The other side, we're up very high. Let's do the same thing for the other asymptote. The other asymptote is at 3. What's a number that's a little bit smaller than 3, to the left of 3?
2.9.
So 2.99. Just to the left, you're at -400. And if you go even closer, it's just going to go even further down, -40,000. Okay, so it's way down. And you can probably guess what's going to happen. We're going to be way up on the other side. What's a number a little bigger than 3? 3.001. If you put in enough decimals, it's just going to round it. But if you highlight it, you can see that it's not really that number. Okay. So a little bit bigger than 3, we're up at infinity. So way up here. As far as the middle, I think we've got enough points to do the middle. Okay, we've got 4 points between the verticals. You've got to stay close to that asymptote, and you have to stay close to that one. But you have to connect in the middle and go through those 2 points. So it's basically going to do something like this. There's the middle. I'm not really sure what's happening on the left side. I need maybe 2 more x values in this area. What would be 2 more x values that would be good? Negative how much?
10.
All right, -10, or just below the y-axis. -0.1. Okay, so we're about right there. Let's do one more kind of in the middle of these 2 dots. -4, -5, yeah. -4, we're a little bit lower. So 1, 2, 3, 4. We're about right there. All right, so what's going to happen here? We've got to stay very close to this. Go through that point. But I can't cross the vertical. So it's going to get to it. It's just going to be forced to curve down. Just like this. So there's that. And now the upper right is kind of going to look like the lower left. But let's get another point. What's a point that would be in this right section? So +10, just above the y-axis. And let's do 1, 2, 3, 4. Let's do 5. Point 0.3, I guess. 1, 2, 3, 4, 5. 0.3. Alright, so let's draw this piece. So it's going to come down, curve, and basically go like that. Is it ever going to touch this horizontal? Nope. It's going to get closer and closer as you go left and right. The only place it does cross is right in the middle. Let's see how we did. Okay, there's the left, there's the middle, and there's the right. It's pretty good. It's a little flatter in the middle than I drew it, but I mean it's still a really good sketch. Any question on that? Yeah.
So there is a hole in the center.
No, there's no holes. There's two vertical asymptotes because there are no common factors in the top and the bottom. To have a hole, you need an x minus 1 in the bottom.
So it just goes through without its own.
It goes through, yep, without any problem. No, no holes at all. All right, let me adjust the homework. I gotta just fix it real quick. Okay, so I changed a few questions. Just took a few out. So 1 through 5, odd. Okay, 9 through 11, that's all. 15, 19 to 22 is all. And then 23, 25, 29, and 30. Okay. All right, and we'll take a look at that tomorrow, and we'll do a couple more of these types of graphs. And then between Wednesday and Thursday, we'll finish the last section.